Good afternoon. Can you all hear me?
Yes, sir.
Okay, thank you. Right. We will continue from yesterday's differentiation. We have used the differentiation technique to identify in terms of application to see the gradient or the slope of a curve, how we can apply that. Then we have seen how to identify the maximum and the minimum point, right? Later we will see some of the applications of this, right? Okay. All right. When you come to the application, right? Normally, the applications are the real world application. Yesterday I spoke about the maximum minimum to get the rainfall information, to get the production information, etc. So as you all know, this is y-axis, this is x-axis, this is plus, this is minus, where this is minus, this is plus. Usually, the real world example are coming in the quadrant 1. So always x is positive, y is also positive. Don't forget that. When it comes to applied, right? When it comes to applied, because we don't say minus 20 kilogram of production, no, right? So minus 20 liter of milk produced, no, right? The rainfall is minus 80 milliliter, no, right? In real world example, it is coming in quadrants, first quadrant, right? At the later stage, maybe after next class, we could talk about a little more application on derivative and the integration. That is the next section that we are going to talk about. Yeah, somebody raised your hand. Yeah, anyone? By mistake only, or do you want to ask any questions? Because it indicated on my screen, somebody with the name has raised the hand. Anyone? Right. If not, we will continue. Right? Right. Today, I'm going to talk about the last section on differentiation. Up to now, we were talking about a function, right, with two variables. Y is a function of x. So this is how we indicate y is a function of x. So whereas we have two variables, one is a dependent variable, the other one is independent variable. Right, now if you have, suppose let's say y is a dependent variable, depend on two variable, let's say x and z. Y is depend on two variable, not like earlier case. The earlier case, y is depend only on x variable, only one variable. So we don't have any problem. So we take the derivative of y with respect to x, only with respect to x, because we have only one variable. Here, there's a chance by dy by dx. That is one option. The other option is dy by dz. You see, because two variables are there. If you have three variables, anyhow, for our session, we will start with this altogether two independent variable. So this is how two independent variable written for a function. Y equal function of x and z. So dy by dx and dy by dz. So when how to handle this? This is what we are going to learn as the first term today. So here, not like in earlier case. In earlier case, we had only one independent variable. Here we have more than one independent variable. So when you talk about the derivative of one independent variable in the presence of another independent variable, it's called as partial Jiva singing, Samara Jiva, yes. Partial differentiation. So you understand what is the meaning of partial differentiation. Because when you have more than two independent variables, you have to differentiate with respect to only one variable in the presence of the second variable. So it is called as partial, not fully partial. So that from the partial differentiation, the product coming out is called as partial derivatives. So today we are going to see how to reduce the partial derivative. Right? Little on theory. Consider before we do some practical aspects, examples, we will have some theory. Consider a function f. Consider a function f. Let's say z is a continuous function again with the variable x and y. So here the z is the dependent variable, x and y are the independent variable. Y is the dependent variable. Sorry, z is the dependent variable, x and y are the independent variable. Right, now if write down some of the notes, how to get the partial derivative for with respect to x and with respect to y. If function, right? If f is a function, if f is a function of variable, is a function of two variables, x and y, two independent variable, right? X is sorry, f is the function of two variables x and y. The partial derivatives, of z with respect to x is given as, so we are going to see what is the partial derivative of z with respect to x. So when you consider partial derivative of z with respect to x, then y will be treated as constant. Don't forget that y will be treated as constant. When y will be treated as constant, when you consider the derivative, partial derivative of z with respect to x. So that can be written as, Here we are using daba z by daba x. So this is indicating the partial derivative. It is same as dy dz by dx, same thing. We use d terms for the full derivative. For the partial derivative, to identify it as, we indicate daba. So this is the derivative of z with respect to x is equal limit Birudan. Can you mute it? Hello. It is echoing. I cannot do the lectures. Birudan, can you mute it? This is the problem with the latecomers. Always coming at the end. So my con problem. So the partial derivative of z with respect to x is given as, somebody try to play around. You see, already some has made the drawing on my pad. Who is that?
Abu, awal kita class.
So I will catch the person who has drawn on my screen now. Give me a couple of minutes. He will be removed from the class. You will are playing badly. You will are not behaving like adult, right? Right. So that partial derivative of z with respect to x is given as limit of a function x plus delta x y minus function of x and y divided by delta x when delta x reaches 0. So this is how the theory says how to find out the partial derivative of a function. Here we are finding the partial derivative of z with respect to x. Right? Similarly, we can write the partial derivative of z with respect to x. So we could say the partial derivative of z with respect to y is given as, right, partial derivative of z with respect to x right. The partial derivative of z with respect to y is given as so when you give the partial derivative with respect to y, the second independent variable x will be, right, x will be treated as constant. You see, x will be treated as constant. But mute it, right? So I made a mistake, I think here. This is delta x. Delta x. So this is given as, right? This is given as, because once we come for the teaching, people change our mood. So somebody has changed my mood now because after drawing on the pad, now it will not go away until we switch off the program. So you see, like small kids. Daba z by daba y given as is given as limit of again function of x where y with a small change in y minus function of xy divided by delta y where delta y reaches 0. This is little unclear. right? Okay, so this is how we come up with the partial derivative. There are some partial derivative notations. This is one notation we have already seen. This is another notation that is also we have seen. There are a couple of other notations. What are those? For example, this is daba square z by daba x square. Daba square z by daba y square. Daba square z by daba x daba y. Daba square z by daba y daba x. You see, couple of notations, right? 6 different notations. We are going to see for a given function, how can we get these 6 different notations, right? Okay, so hope you have taken down this. I'm going to remove this software and coming back again. Huh? Give me a second. Can you all see the screen?
Yes, sir.
Yeah, good. So we are going to see all these 6 different components for a given function, right? Keep in mind, when we find the derivative, partial derivative of z with respect to x, the rest of the independent components will be treated as the constant. So that we'll have to keep in mind, right? That we'll have to keep in mind. Right, this is my example. Right, 2x square y square, y to the power 3. Right, now this is my function. So z is one variable, x is another variable, y is another variable. We have altogether 3 variables, x, y, and z. X, y are independent and z is dependent variable. How to handle this? Daba z by daba x. Daba z by daba x. So when you differentiate with respect to x, y will be treated as constant. Already 2 is constant. Y also will be treated as constant. So we keep the constant 2y to the power 3 first. Then you differentiate x square. So that is 2x. So equal 4xy to the power 3. So that is the answer. Partial derivative of z with respect to x. Look at very carefully. So the second variable will be treated as a constant. So here the constant is multiplied. So that is same as 2. So 2y to the power 3 will be treated as constant. Right, daba z by daba y. What is that? Now we treat x as the constant. So keep the and x square as a constant. You do the differentiation with y to the power 3. 3y square. So that is equal to 6x square y square. So that is the answer. Here we always differentiate with respect to one variable. So the other variable will be constant. Right, now what is this? Daba square z by daba y daba x. So that means the derivative, the function which has been already differentiated with respect to x will be now going to be differentiated with respect to y. So the component which has been already differentiated with respect to x will be going to be differentiated with respect to y now. Right? So what is that? If you differentiate 4x y to the power 3, now we have this 4x is a constant. You differentiate this component, that is 3y squared. So that is equal to 12x y squared. Similarly, if you want to differentiate daba square by daba z, which has been already differentiated with y, now you are going to differentiate with respect to x. That means you are differentiating this component, right? Which has been already differentiated with respect to y. Now you are going to differentiate with respect to x. I will come to that reason. So that is equal 6. You are treating y also as constant. So 6y square into differentiate that is 2x. So that is equal 12x y square. You see there's a similarity. Here we have only 2 independent variables. There's a similarity. Same. Whether you do first variable differentiation first and the second variable later, or vice versa, ultimately you will end up with the same answer. So that we could say daba square z by daba x daba y, which is equal to daba square z by daba y daba x. Is it clear to everyone? Any explanation needed? Further? Anyone?
So here, with respect to x, with the respect differentiate with the respect of x, is
one we have done twice.
First
Which
one, yes.
Which one? This one?
Yes, here.
Yeah.
Can you a bit explain the 2x?
No, I said when you differentiate with respect to x, what is the other independent variable along in the function? What is the other independent
Y.
variable?
Y.
Y. So what should we do with y? Here I have already mentioned. If I differentiate with respect to x, y will be treated as a constant. Right? So similar to y also. If we differentiate with respect to y, who will be treated as constant? The other variable, which is x. So here, this is the question. In this question, we are differentiating with respect to x. So who will be treated as constant?
Y.
Y. So then constant mean it is same as another number, isn't it? We already talked about constant. What constant mean it is number. So we keep because this constant is multiplying. Don't forget square, right? Multiplied by y to the power 3. So when you multiply, so we treat the constant like this. So bring the constant onto the left side. Then you differentiate x square.
Right? So here, yes, when multiplied by y, we here didn't mention x square. Is it come as previous equation? It's come as 2 square, it comes as 2.
So when you differentiate x square,
Yes.
it is 2x, isn't it? Because we are
Okay.
differentiating with respect to x. What is the derivative of x square with respect to x? We are differentiating only x square.
X
That is
square.
2x.
Yes.
2x. So,
Yeah.
right?
It's okay, sir. Thank you.
Okay. So you got it there because we are differentiating only x square because the rest of the components treated as constant. Constant, multiplicative constant. It's like treating something like, right? If you have a function 10x square. So this is a constant multiplied by x square. So dy by dx, what we do is we keep the constant there, isn't it? Then only we differentiate that 2 into x. Similar concept. So here the constant is 2 and y to the power 3. So keep they are multiplicative constant. Right. Any other questions? Okay. So if you are not sure, familiar, ask questions. Right. Okay. Now we can find out the other components. For example, we can find out this is from here. I will erase this. So from here, we could find out daba square z by daba x square. That means the one which has been already differentiated with respect to x, again we are doing differentiation with respect to x. It's like taking the second derivative, similar to taking the second derivative. Can you remember? So we keep 4y to the power 3 constant. We have only one component x, so it is 1. So that is the answer. Right? Similarly, we could do daba square z by daba y square, which is 6x square. We keep it constant into 2y, which is 12x square. So we have gone through all 6 components. Right? This is one component, this is another component. We have already, right? So this is another component, another component, another component, and the last one is this one. Okay. All right. Any questions? Any questions? Right. I will give one more. Here, u, that is the another variable, x to the power 3. So this is u is similar to z minus 2x y square plus 2y to the power 3. How many variables are there, first of all?
3.
3. What are those variables?
U, X, Y.
Huh?
U, X, Y.
Ux, u,
Y.
yes, u is one variable, x is another variable, y is another variable. You see, yesterday, I don't know, everyone has got it, right? Yesterday, annotation, the person who has written down is Patnayaka Mudaliyanse Sehani Veeransha. Veeravansha. You see, we have the recordings. I will play all the recordings and catch you up. Don't write it on my screen. Right? So don't write it on my screen. Today, one also will be caught very soon. don't write it on, you all are not children, right? You all are adult. So, right. Because I asked who wrote it, you could have simply come up with saying your mistake. Then we could have accepted. වරදක් කළා ශබ්ද නොකරත් තින්නේ නේ. මාර කට්ටිය ලංකාවේ එම තමයි පුරුදු කරලා තියෙන්නේ. Right. How to do it? Here we have three variables. Again, we'll have to go for the partial derivative. How to look at the partial derivative? Daba u by daba x. So always keep that in mind. When we consider the partial derivative with respect to x, y will be kept as a constant. So here x and y are the independent variable. So that y will be kept as a constant. Can somebody tell me how to differentiate this with respect to x? Anyone? How to differentiate this in a normal way? That is 3x squared. Fine, finish. Minus this same minus here, right? Now we'll have to differentiate this. Now, when you differentiate it, this is not only one component because several components are there, right? How to differentiate that component? Anyone?
Two y square
2y square into
and
differentiate
into
the x. If you differentiate x, what is the answer?
1.
1. So we don't need to write 1 plus differentiate that with respect to x. What is that?
2y square.
Huh? So what did I say? When you differentiate with respect to x, y will be considered as a constant. So here, no any x component, only y
2y
component. Huh?
2y power of 3.
No,
0.
0, because I said y is also considered as constant. If y is considered as constant, what is the derivative of that? This is constant, this is constant, so derivative of constant is 0. Right. Similarly, daba u by daba y. Can you tell me each component?
Again 0.
Yeah, first part will be 0 because no any y component there. Minus, sorry,
4y.
here, huh? Here. No components there. Yeah,
4y.
y. What is the constant here? What are the constant components?
2x.
Huh?
2x.
2x is a constant. So keep the constant first. Then you differentiate y square with respect to y. To y. Isn't it? Right. We will solve it later. Minus. What is the derivative of this with respect to y?
Six y.
Huh?
6y square.
6y square. You are eating, taking one component, swallowing. Right, 6y square. Isn't it? 6y square. Got it? Is it plus or minus here? Plus, isn't it? Right? 6y square. So you can write it as 6y square minus 4xy. So that is one. Now tell me, what is daba square z by daba y daba x? You differentiate this component with respect to y. Anybody?
12y minus 4. 12y minus 4.
Y. So we'll have to differentiate this component with respect to y now.
Minus 4y.
So this is 0, isn't it? First component 0 minus 4y. Similarly, if you further differentiate this with respect to x, so that is equal. So this component will be treated as constant. The answer is minus 4. Isn't it? So you see, it is equal. This is equal. This already we said. You should get the same answer. Otherwise, something wrong. Whether you differentiate with respect to x, then you differentiate with respect to y, or you first differentiate with respect to y and then differentiate with respect to x, you will have the same answer. Clear? I think you have some examples in the tutorial. Right. There are 6 components. I will start with the first one. For an example, let's say I have a example. Let's say k into square root of x square plus y square. So this is my function. Here we have 3 variables. Z is a variable, x is a variable, y is a variable. Then what is k? K is a constant. Doesn't matter whatever the constant. K is a constant. It's like a number. 10 or 15 or whatever it is. Can you find out the first component, daba z by daba x? Before that, we can have a smaller version of it, right? So that is equal k into, how we can write this? X square plus y square, whole thing to the power. Can we write like that? Yes or no? This component, can we write like that?
Yes.
Yes, we can. So that is to simplify the component, is it? Otherwise difficult. Right, now can you differentiate with respect to x? So we have k multiplied by half into x square plus y square. We are applying the chain rule. Half minus 1 into differentiate this component which is inside with respect to x into 2x. So here 2 cancel off. The answer is k into x square plus y square To the power, anyone? To the power?
Minus half.
Minus half. So how we can write this, for example? I can write this as k divided by x square plus y square to the power half. Can I write like this? Yes? Yes. As a homework, find out the rest. Daba z by daba y. Daba, right? Then daba square z by daba x square. Daba square z by daba y square. Daba square z by daba x daba y. The last one daba square z by daba y daba x. Can you find out all these 5 components? Actually, these two will be equal. That means we will have the same answer. All right. Okay. Any questions? This is about the partial derivatives. Any questions?
Excuse me, sir. Can you explain that second order derivation once again?
What do you mean by second order derivation?
Earlier you explained for the previous example 4x into y cube. That
Which one? This one?
oh yes,
Which
sir.
one?
This one.
Yeah. What do you want to know?
Want to know how to differentiate the second time.
Second time mean what is? I mean, what is the notation? What your notation?
Daba squared z divided by daba x squared.
Yeah. For example, let's say this is the function, right? This is the function. So what is daba z by daba x? That is 3x square minus 2y square. Isn't it?
Yes, sir.
Right. Then if you differentiate further with respect to x, so this is how you write it out. So what is that? Lowensia. Lovesia. Sorry.
Oh yes, yes, sir. I'm here.
Yeah, Lovesia, tell me now how to, because again you are going to differentiate with respect to x. So this is your present function to be differentiated with respect to x. So how to differentiate that? Tell me.
This time x should be the constant.
Why? Because I'm going to differentiate again with this is actually, right? Daba is that daba, right?
Yes.
This is actually daba is that by daba x multiplied by daba z by daba x. This is what I said. Do you understand? So
Yes, sir.
this is already we have differentiated with respect to x. Now again we are differentiating with respect to x. Okay.
Okay.
So that can be written as this. So now we are going to differentiate again with respect to x, which has been already differentiated with respect to x. So what is the constant now? Again, now the constant is y.
Y.
So what is the answer now?
6x.
Exactly, 6x. So that is your answer.
Okay, sir. Thank you.
All right. Okay.
Thank you, sir. I am.
Okay. Any other questions? Any other questions? So it is true for y also. Dabba square z by dabba y square. The story is same. All right. Look at this. Another example. Let's say u is one variable, x is another variable, y is third variable. So three variables are involved, u, x, and y. How to differentiate this? Anyone? Before differentiating, can you convert this? Can we, how to handle this kind of, because x to the power y, if x to the power 2 or x to the power 3, we can differentiate. This is x to the power y, another variable. We cannot do it directly. Any suggestions by any member? Any suggestions? Any suggestions? Anyone?
Here we
Ravi?
take
Yeah, Madhavi?
we take as two variable.
All three are variable. This is variable, this is variable, this is variable. So how we can bring it in all the variable in one line? This is in power. What is the
Yes.
technique available?
Differentiate
The
with
power minus
y.
minus 1.
Not differentiating.
Logarithms.
Hema Tarani, yes. Veerasinghe?
Yx,
Huh?
yx to the power y minus 1.
Once again,
Yx to the power y minus 1.
y,
X,
x.
y to the power y minus 1.
No, because again, this is one layer, this is another layer. Can you bring it in one single line? Because this is a variable, where this is a variable, again, this is number, it's more complicated.
Take log both sides, sir.
Exactly. So that is the best way. Take the log. Log u is equal log x to the power y. How we can write this further? Log rule, I mentioned about it. This we can write it as y into log x. Can I? Yes or no?
Yes, sir.
Yes. Now my question is simple. Log u is equal y into log x. Now try. Now try. For example, I will take a very simple one. We differentiate, right? This. When you differentiate log u, 1 over u into dabba u by, let's say, dabba y. I'm differentiating with respect to y. Later we will see with respect to x is equal. This is becoming as constant, isn't it? Because we are differentiating with respect to y. So log x will be treated as constant. Differentiating y is 1. So from this, you could say dabba u by dabba y is equal u into log x. So u we already know. What is u? What is u from the equation from the function u is equal x to the power 5 into log x. So that is the answer. Similarly, if you go to if you differentiate with respect to x, right? If you differentiate with respect to x, so what is 1 over u into daba u by daba x is equal, anyone? Anyone? Which one is considered as a constant?
Y.
Y is kept as a constant. Then differentiate log x. If you differentiate log x, 1 over x, isn't it? Into 1. So here we don't need 1. So that is y over x. Right? So we could write it as daba u by daba x is equal u into y over x. We know u is x to the power y into y divided by x. Got it? Clear? Right. You can think about further. Right? Others are a bit complicated if you go for double square level. But still you can again do the log form and so on. All right? Right. Any questions? Yeah. Suppose, let's say, if you have a function like this, u is equal x divided by x plus 1. Now what to do? Now we'll have to refer back our previous rule. For example, if you say daba u by daba x, we consider this as u, this as v. Can you remember u into dv by dx? Without complicating, I will write it as z. This is, I will write as z. So otherwise you will be complicated with the other u and v format. So can you tell me how to handle this? What is the formula? If you consider this as u or this as p. Anyone? Today holiday attendance is a little less compared to yesterday. Almost 20-30 people are missing. 20-30 people are missing. Why? What is the reason? Yeah. Right. I mean, tell me how we can do this differentiation, partial differentiation. You can take the numerator as u, denominator as v, apply it. Tell me the sequence. Anyone? Madhavika? Oh. Ahmad? Anyone? Loventia?
Yes, sir. The common formula. Do I need to tell that one?
Yeah. I mean, for example, y equal u by v. Can you remember the rule?
The rule is v into
So what is v here? What is v here?
Mean x plus y.
X plus y is v into,
U dash, we have to derivate this x.
yeah, what is the derivation of x with respect to x?
That is 1.
1. Then,
Minus
mhm,
u component will come x
okay.
into, then we have to derivate x plus y.
If you derivate x plus y with respect to x, what is the answer? If you derivate x first component, what is the answer?
That is 1.
1.
1 plus y.
1 plus
1 plus y.
y. How does this y comes?
No,
Because-
only 1, sir, because here y is constant.
This is partial derivative. Don't forget. So here 1 divided by,
Divided by v squared, mean x plus y squared.
right. So you can rewrite it x plus y, right, minus x, whole thing divided by x plus y, whole thing square. You see? So you can try with respect to, right? So this we can further solve it, isn't it? This x and this x will cancel out. So we could write it as y divided by x plus y whole thing square. Can we? Yes, I forgot. So this is the answer. Similarly, find out daba z by daba y. Now, I will give you a couple of minutes. Everyone, find out daba z by daba y. Anyone? What is the answer? Final answer. Again, you take it as u and v. So daba z by daba. Anyone? Madhavi?
I didn't get the final answer up to now. I'm solving it.
Flow. I mean, the first component.
X plus y minus y
X plus y.
minus y
What is du by dx?
d x
It's 0.
and denominator is x plus y square.
Yeah. I'm asking about numerator, so that is fine. We will flow it. Yeah. What is du by dx?
It is 0, sir, because here u is x. No, it should be the constant, so that
Yeah,
should be.
derivative of u is x here, so that it is 0. Derivative of constant is 0. with respect to y. Minus, yes. Then u.
Again, minus u, that will come as it is. So x
Then
into, we
what
have
is
to
the
again,
derivative of
v
x plus
dash means
y with respect to x?
that is 1.
1 divided by x plus y whole thing square. Right? So what is the final answer?
Minus x over x plus y
Yeah,
squared.
here this is 0. This component becomes 0. So minus x divided by x plus y whole thing. Got it? Right. So we'll have to bring all the concept of what we have learned in the other roots. Right. Another example, maybe final one. Right. Again, z is equal x minus y into x plus y. You can do taking this as u, this as v. That is one possible. Or you can multiply this. That is also possible. If you multiply, this become x square minus y square. Isn't it? So that is also less easy. Either way is okay. Either this way or that way. Get the daba z by daba x. Very simple. Anyone? I'll ask a new person. Samarajiva 24020.
Yes, sir.
Yeah. What is the answer?
Minus 2y.
Minus
2y.
minus
2y.
y. Y minus 2y. My question. So you have this. Differentiate that with respect to x. Sonali 24046 Sonali. Bhagya 24058. Kavipriyan 24080. No one, it seems no. Cruz.
Sir, 2x, dava sato dava x is equal to 2x.
2x, good.
Yeah. The
Yeah.
other one is minus 2y.
Yeah, this is daba z by daba x
X.
is 2x.
2x.
But y will be considered as a constant.
Comes
What is daba z by daba y? Then x
minus
will be
minus
considered
2y.
as constant. So
Minus
yes,
2y.
minus 2y.
Right.
Okay.
Dava
Right.
sato dava by dava x is equal to 2.
Yeah, the rest you can try. Okay.
The other one is dava sato dava x dava y is equal to minus 2.
Okay. Right. This is just to show you how to differentiate. Right, any questions? Any questions? If you have any specific questions, still we have time to answer. Right? Right. Now we are going to move to a new section that is called integration. Integration. New section will be on integration. Right? Before we talk about integration, let's look at some concept behind the area under the curve. Area under the curve. The area under the curve. So if you have x and y axis, if you have a function, let's say y is a continuous function with only one variable, let's say x variable, right? So my area under the curve above x-axis between 2 points, let's say A and B, right? And x equal A and x equal B. So this is the area that I am talking about. So this area is, let's say, A, right? A is the area under the graph. Area under the graph above the x-axis and between x equal A and x equal B is, right? How we can find out this area? How we can find out the area under the curve above the x-axis between two x values, A and B. So that is we are going to see now how to find out the area. Example, right? So I'm going to take a function. I will take a very simple function, right? Easy function. Let's say y is equal x. The function is y is equal x. This is my function. Y equal x. When x equal 1, y is also 1. When x equal a, y is also a. When x equal 10, y is equal 10. Right? So I can divide. Suppose, let's say, if I want to find out the area, when x equal a, right? So it is the area that I'm talking about, right? So we can find out this area in a simple form. What is the area here? Demarcated. I'm talking about this area. So in a simple form, half into base. What is the base? It is again A into height, vertical height. This is into A. So that is equal half A square. So we can write it as A square by 2. Right? How this value comes? A square by 2. How this value comes? Right? So we are going to divide this whole graph. Right? I will remake it before drawing it. Looking for easy way to everything is gone. Yeah, I will draw it separately. So again, the same function y is equal x, right? I'm going to divide this area into small number of equal size x value. Right? Equal value of x value. Right? So divide. Here this is A, this is 0, 0 to A intervals. Into n equal Can you all hear me?
Yes, sir.
Okay.
Yes,
Sir, is there any,
Hello?
sir, in and out, the connection is dropped. I'm not sure in here problem or sometime in the screen, sir's connection is poor. It is indicated.
Yeah,
Several times connection was dropped.
yeah. But I don't know
Excuse me,
about that.
excuse me, sir. I also couldn't hear the lecture.
Now you can hear, right?
Yes, now
Yeah,
we can.
yeah. Mega, suddenly there was a drop, I think. I don't know. I don't know whether from PGI side or from your side, but I don't know something from. Now you can hear, right? Yeah,
Yes.
because this area which I said will be divided into different. Hello?
So that integration is a graph. Can you please go to there?
I didn't hear. I didn't hear. Voice is not clear.
Integration is not a graph.
You'll have to speak out loudly, otherwise I don't hear. My speaker is good. Something wrong with your speaker. Integration graph, earlier one.
Yes, earlier one, sir.
This one. Because I have.
Not previous one, sir.
This is the previous one.
Starting. Yeah.
This is the previous one. Now already I have erased some of it.
Okay, sir. Okay.
Right. So we are dividing the total length of A into smaller interval of equal size, n equal parts. Each part is h. So I will put it as h. Each of these are h, small components, right? So we could write it as A is equal n into h. So from that, we could say h is equal A divided by, okay, h is a smaller unit that we have divided. So h can be written as A divided by. So here we can take two rectangle to find out, because we want to break into several rectangles and get the area, because we want to find out the area or under the curve above the x-axis in between 0 and A. So that we could find it out using our technique. It's called as, two techniques are there, right? Called as circumscribe. Circumscribe method. I'll put it as SN method. Inscribed method. It is indicating simple SN. What do you mean by circumscribed and inscribed? We take the rectangle, right? So this is one rectangle. You divide in such a way the smaller unit. So this is one rectangle, this is second rectangle, this is third rectangle, this fourth one, fifth one. So this method is called as inscribed method. Sorry, this method is called as circumscribed method. The method in the blue color is called as circumscribed method. This is indicating the outer side of the triangle, rectangle, right? So this is one rectangle. And so inscribed method indicating this rectangle from the lower side. So your first rectangle would be this one. Second rectangle, third rectangle, fourth rectangle, fifth rectangle, sixth rectangle, and so on. So this is your first rectangle. Okay. So in other term, if you draw it, right? So this is your circumscribed method, right? So this is circumscribed method, taking the rectangle. Inscribed method, simple SN method. This is from smaller h. Assume that these are smaller h distance, right? So this is your first rectangle, second rectangle, third rectangle, fourth rectangle. So this is your first, second, third, fourth. But in circumscribed method, this is first, second, third, fourth, and so on. Right? Rectangle. So these are two methods. let's talk about two methods. Finally, we come to a conclusion whether it is a first method or second method or circumscribe or inscribe. We will find the same answer. I'll give a simple example, then we will go further, right? Right. Now, if I want to find out the area of the above case where y is equal x, right? So in the circumscribe method, capital SN, that means first rectangle plus second rectangle. So this is the first rectangle. What is the x and the y value? Anyone? We want to multiply. What is the width? What is the width here? That is h. What is the length there? That is also h. So we could say that is the dimension of the first rectangle. Plus dimension of second rectangle. Anyone? H into 2h. Third one, h into 3h. Plus likewise it goes. The last one, h into nh. Do you all agree? So that we could say h square into 1 plus 2 plus 3 up to plus n. So we can write it like that. So that is says as capital Sn is equal summation. Before summation, we can say h square summation of I, where I is from 1 to n. Maybe you might have seen some kind of notation, summation notation in statistics also. You mean add all these components, right? So this summation notation, this is given as summation I, where I is from 1 to n, can be in the series, it can be said as n by 2 into n plus 1 in a simple form, right? So we can substitute this instead of that. So we could say capital Sn is equal h square into n by 2 into n plus 1, right? Okay. Right. Now, it is equal. We can simply multiply further, right? Instead of h, we can write a by n. Could you remember earlier I said h can be given by a by n, right? So when you say h square is a by n, whole thing square, right? Into n by 2 into n plus 1. I didn't do anything, I am simply substituting. So you can expand this. This is a square n by 2n. Sorry. Yes? This is n square, 2n square, right? Plus, we will multiply this, not at once, we will do it step by step. So that is easier for you. So this is a square by n square, n square by 2 plus n by 2. To expand further, you could say a square, n square divided by 2n square plus a square n divided by 2n square. right? So here n square cancel off. Here 1 n cancel off. You could write it as a square by 2 plus a square by 2. Right? Now, when you apply the limit of this function, a square by 2 plus a square by 2n, when n reaches infinity. When n reaches infinity, what is the limit of this, anyone? So this is a square by 2 plus n reaches infinity. So this will become 0. So the answer will be a square, sorry, a square by 2. A square by 2. All right. So this is what we have already said, the area of you see, area. How does this area comes? A square by 2. Right? We have for the formula, how the actual area comes. This is actually the area concept. Right, then they have found the shortcut to find out the area for a function. Similarly, inscribe method, as we said, the first rectangle start from this, you see. First rectangle start from here. This is first one, second one, third one, and so on. Not like in the earlier one, right? So in the inscribe method, we could write it as simple Sn, finding out the area, h into h, that is your first dimension of first rectangle, dimension of second rectangle, h into 2h, plus dimension of third rectangle, plus and so on. Right? So that is equal. I mean, at the end, it is coming as h into n minus 1 h. The last rectangle will be 1 minus n. One rectangle less than the total rectangle. Right? So we could say that is equal h square into summation of h square into 1 plus 2 plus 3 plus and so on. Last one is n minus 1. Okay? So we could say this as h square into summation of I, where I is starting from 1, but ending at n minus 1. We could expand this, where what is this summation I, where I is from 1 to n minus 1, can be written as n by 2 into n minus 1. Right? Now substitute on our equation. Simple lesson to find out the area h square. Instead of this, can say n by 2 into n minus 1. As we said earlier, this h is again a by n, whole thing square, into n by 2 into n minus 1. Right? Then we can expand this further. Right? A square, n square into n square by 2 minus n by 2. If you further solve it, a square n square divided by 2n square minus a square n by 2n square. As you all know, you cancel the n squares here, then you cancel this n, so you can write it as a square by 2 minus a square by 2. Now you apply the limit when n reaches infinity. That will be given as a square by 2 minus 0. So that is equal a square by 2. So the area is a square by 2. So what we emphasize here is whether you use circumscribed method or inscribed method, whatever the method that you are using, we will end up with same area. How do we find out the area here is we are dividing the given area into different rectangles, right? So in earlier case also I mentioned about the area under the curve, right? So this is the function y equal fx, right? So I want to find out the area between two x values. Let's say this is one x value, this is another x value. Let's say this x value is a and b. What I do is I try to make this into different small rectangles. So that is what I'm trying to do it, right? Small rectangle, for example, assume that these are small rectangle, even though it looks very big, but small rectangle. So I simply make them into rectangle, very small rectangle, so that it's easy for us to get the values of each rectangle. Then we accumulate the values of each rectangle. So that will give you the area for the given area under the given function, area under the. So that is the concept we have. Even in integration, that is the basic concepts. That is why I'm bringing this area under the curve. Here, for example, in our previous example, we have given for a linear function, that is easy. This is a curve function, isn't it? This function is also a function of x, where this is a curve function. So for the curve, any function, we can divide the area into smaller rectangle. Then we find out the area of each rectangle and accumulate it. So that is the concept of this integration. Okay, so that is what the concept of integration. We can do certain other curve functions. I don't need those. So we will go directly to the integration functions. So the integration functions basically, or the concept of integration, is the area under the curve, right? Right. Little on theory, right? We talked about theory. Usually I don't ask theory, right? Right, now definition. Definition: the area enclosed by a given function, let's say y is equal to fx function, where the x value ranges from a to b, So that is given as the area from A to B is the limit, right, of that functions, where we bring them into the rectangles, different rectangles. So function of xi into delta xi, right, where I is from 1 to n, when n reaches infinity. So this is how we can write it as a function, where area of a given function between two x value, a and b, can be written as a limit of a given function where n reaches infinity. N reaches infinity. Okay? So this we could further write it as, right? This is how we write it as whatever in the first equation can be summarized in the second equation. So this is given as, this is how we write the integration function. The integral of f function with respect to x from A to B. A to B. The integral of function with respect to x from A to B. So this is how we can express in terms of text what we have written there. It is the integration of function, given function, with respect to x from the range A to B. From the range A to B. Right. This sign is called as integral sign. This sign is called as integral sign. Right? Integration is the addition of area. We want to see why we want to add the areas. Integration is the addition of areas. Right? So this, when you talk about addition of area, this is A is called as lower limit. B is called as upper limit. A is called as lower limit. B is called as upper limit. Right. Now, look at this function. This we have already, for last 2 weeks, we were talking about this. What is this process? What is this process?
Differentiation.
Yeah, this process is called as differentiation. What is this?
Derivative.
Derivative.
Yeah, derivative. This is a function, given function. So, if you do a differentiation of a function, the product that you will get is derivative. Now, suppose, let's say, if I have a product, derivative product, if I reverse this function, this is called as anti-derivative. differentiation. Right? This anti-differentiation is actually called as integration. Got it? Anti-differentiation is called as integration. So this is the relationship between differentiation and integration. So they are going together. They are going together. Right. Let's see. We will start with very simple example. Now I got a derivative as this. I got a derivative as this, 2x. So what is my original function?
X squared.
X squared. If you differentiate, it becomes as 2x. Let's say my another function. If you differentiate, what is the answer? If you differentiate x squared plus 8, what is the answer?
2x.
Yeah, that is also 2x. This is also 2x. So how to differentiate? Therefore, when you differentiate, when you integrate the function, in addition to that, we always say plus c. C is a constant. C is a constant. Right. Now, one more. My derivative is given as 3x squared. Find out my function.
X square.
Hmm.
X square plus C.
Hmm.
X cube plus C.
Yes, sorry. X cube plus C. Sorry.
Yeah. X to the power 3 plus. Right. Now, we can do it for any given situation, but we can find out a formula or the rules shortcut to find out the integration. Suppose, let's say my function is given as, derivative is given as x to the power n. So that we can say integration of x to the power n with respect to x. We want to integrate that function with respect to x. Is given as x to the power n plus 1 divided by n plus 1 plus c. So this is the rule, right? However, for all n, when it takes any number, doesn't matter, except for -1. I will tell you later when the time comes why it is not for -1, right? N can take any value other than -1. So this is how the integration process is. For example, integrate a function x to the power 3 dx. If you integrate x to the power 3 dx, all right, what is the answer? use the rule. We'll see some of the rules one by one. Integration rules. See the first one. Yeah.
X to the power 4 divided by 4 plus C.
Yeah. So apply the rule. So x to the power 3 plus 1 divided by 3 plus 1 plus c. So that is equal x to the power 4 by 4 plus c. If you have a doubt, try to differentiate and see whether you are getting x to the power. Try to differentiate and see. So no problem. Right? Another example, x to the power 3x to the power 2 dx. Yeah, we have done. Give me a second. 3x to the power 3 dx. Anyone?
3x to the power 4 divided by 4 plus c.
Yeah. So that is 3 into x to the power 3 plus 1, which is 4 divided by 4 plus. Right? So this type of integration is called as indefinite. Indefinite integrals. So these are called as indefinite integrals. What is integrals? It is the product. Integration is the process. Integral is the product, like derivative. Integral. So these integrals are called as indefinite integrals. Why it is called as indefinite integrals? See here. Here we are not sure about the value for c. Even though we can integrate it up to a certain level, we are not sure about the value of c. For example, 3x to the power 4 by 4 plus 16. So what is the derivative of this? The same derivative, no differences, because the derivative of constant is always 0. Derivative of constant is always 0. So that here, this kind of integrals are called as indefinite integrals. Indefinite integrals. So no exact precision or no exact value for the constancy. Right? Any questions? Right. Try this integration of 3x square plus 4x plus 3 dx. So we'll have to handle this individually. When you say integration of this, you will have to handle them individually. For example, this is same as integration of 3x square dx plus integration of 4x dx plus integration of 3 dx. Same thing. You do it separately for each and every one. Let's do it. If you integrate 3x square, what is the answer? 1 by 1.
That is x cubed, sir. 3x cubed
X to
divided
the
by
power 3. Yeah, x to the power 3. That means 3x to the power 3 divided by 3. So x to the power 3 plus,
plus 4x squared divided by 2.
yeah, what is that?
2x squared
Yes, plus,
plus 3x.
mhm.
3x
Yeah,
plus
then you add a constant. Always don't forget to add a constant, right? Right. Integration of dx. Anyone?
X.
Yeah, because already you assume there is a coefficient of 1. So how we get the derivative of 1? It should have been x. So we could say x plus. What is the integration of a dx? So here a is a constant. What is a dx?
ax plus c.
Hmm. Right. What is the integration of x to the power minus 3 dx? Anyone?
Minus 2x plus c.
Minus
2x plus c.
any other answer? Right, we will look at it. So this is actually integration of 1 over x to the power 3 dx, isn't it? Same as that. Fine. So how to integrate this? That is equal x to the power minus 3 plus 1 divided by minus 3 plus 1. So that is equal x to the power minus 2 divided by minus 2, isn't it? So that is equal minus, right, x to the power, sorry, minus 1 over 2 x to the power 2 plus c. Is it okay? Understandable? So this is important. Okay? Any questions? Try this one. we'll have a break. Yeah? Okay, we can continue. Right, what is the answer for this one? What is the answer for this one? Integration of x to the power minus 2 plus 3x to the power minus 4. So that is equal x to the power minus 3, sorry, minus 2 plus 1 divided by minus plus 1 divided by minus 4 plus 1. So that is equal x to the power minus 1 divided by minus 1 plus 3 into x to the power minus 3 divided by minus 3. Right? That is equal, we could say this is minus 1 over x plus here the 3 cancel off. We could say minus 1 over x to the power 3 plus. So that is equal minus 1 over x minus 1 over x to the power minus x to the power 3 plus c. So that is the answer. Okay. Another example, integration of, let's say, 1 over 4 minus 1 over x to the power 2 plus x square minus x to the power 4 dx. Try this one. Try this one. There's a problem with the software. Right, I will repeat it again. Integration of 1 over x to the power 4 minus 1 over x to the power 2 plus x to the power 2 minus x to the power 4 dx.
Is it zeros?
Hmm? 0, what?
We can rewrite the equation taking the percentage x4 to up. That means x4.
That is, you can try this. Yeah. Yeah, you can write it this as x to the power minus 4 minus x to the power minus 2 plus x to the power 2 minus x to the power 4. That is the first step that you need to do it. Now you can integrate. So x to the power minus 4 by 4 plus 1 by minus 4 plus 1 minus x to the power minus 2 plus 1 by minus 2 plus 1 plus x to the power 2 plus 1 divided by 2 plus 1 minus x to the power 4 minus plus 1 divided by 4 plus 1. All right, so that is equal x to the power minus 3 by minus 3 minus x to the power minus 1 by minus 1 plus x to the power 3 by 3 minus x to the power 5 by. So further, so this could be written as minus 1 over 3x to the power 3. So this plus this, sorry, this minus becomes plus. So that is 1 over x plus x to the power 3 by 3 minus x to the power 5 by 5. So this is your final answer. Any questions? Any questions?
So, excuse sir, in the equation,
Mhm.
after simplifying that, can't we simplify within the bracket? That means,
What is that?
but pluses and minuses are there. So can't we simplify them?
Yeah, you can. You can. Which one? Pluses and minuses. What do you mean? by
The very one, so the fourth step from the down.
Which one? This. Which one?
Up.
This
Little
one.
more. Little more.
This
Upside.
one.
No. Yes, this one, sir.
This one you cannot simplify. No. How? How we can simplify? Right. This is 1 over. This is also 1 over. So that you can say 1 over, and if you want, you can simplify these two. But these two you cannot simplify because the powers are different. You cannot simplify. Right? If it is same power, no problem. Those are in different powers. No? Okay.
Okay, sir.
For example, x square plus x square is okay. That is 2x square. That is fine. Because these powers are different, no? So you cannot simplify easily. Right. Let's move to the other rule. So integration of du by u, which is given as log u plus c. So this is next rule. So here, you should observe here, this is, if this is a function, the derivative of that function, if you find it on top, then it is called as log function. So this is a function. Let's say that function is given as a component u. If you find the derivative of that function on the numerator, then it is going to be a log function. For example, integration of dx by x. So what is the derivative of x? What is the derivative of x? Is 1. So here you have 1 in the numerator. So that is written as log x plus c. Right? Another example, integration of 2x by x squared. Right? Right. So this okay. So this is normally we cancel out this, but in this case, I just show you if this is the case, integration of 2x by x square. See whether the derivative of x square is found there. Then it is called as log x square plus c. Right? Okay. Let's say integration of 2x by x square plus 1 dx. So what is the derivative of x square? That is 2x found in the numerator. Derivative of x square, that is 2x found in the numerator. So that is equal. The integration of 2x by x square plus 1 is given as log x square, sorry, plus 1 plus c. If you differentiate this, this becomes as 1 over x square plus 1 into derivative of x square, which is 2x. So that is same as c. Right? Any questions? Any questions? Any questions? Look at this. Can we find out the derivative of denominator in the numerator? What is the derivative of denominator? Can we find that derivative of denominator in the numerator? So derivative of denominator is 2x. So is there 2x in the numerator? No. So how to handle this kind of cases? So it has to be 2x, but only x is there. So what is this 2? This is 2 is a number, constant. So we can add that constant. So we can write this is same as 2x divided by x square plus 1 into 2 as an example. Right? Isn't it? So that is same as half into integral sign, right? 2x divided by x square plus 1 dx. Can I write like this? I didn't change the structure. I have taken the 1 over 2, which is a constant, in front of integral sign. Constant in front of integral sign. Right? So I can write it as 2x divided by x square plus 1. Any questions? Right. We can continue further. So that can be written as this is equal, half is already there, into log x square plus 1. Plus c. So this is the answer. Any clarification? If you are not sure with the answer, differentiate, you get the answer, this answer of that. Right, try this one. Another one, integration of, let's say, x square divided by x to the power 3 plus 5 dx. Can somebody try in a similar way and tell me the answer? Tell me the answer. Can somebody find the answer for this question? How we can write in the first step? What is missing there in the numerator? Similar to the earlier, huh?
We want to
1
add
over 3.
Yeah, we want to add
3 into
Yeah.
x squared.
Yeah, this we can write it like this. 3x square divided by x to the power 3 plus 5 dx. Can we write like this?
Yes.
Here we have
Sir.
multiplied by 3 of the numerator and the denominator. So that if you differentiate this, that could be found there. Right? So we could write it as 1 over 3 into log x to the power 3 plus 5 plus c. Clear to everyone?
Yes, sir.
Right. Earlier, could you remember when we applied the rule? I said except for -1. Can you remember when I applied the rule? I said n can take any value except -1. N can take any value except -1. All right. So why except -1? Why except -1? So here, when I say integration of 1 over x into dx, right? How we can write this? Sometimes people might write integration of x to the power -1 dx. Can we write like that? Yes, we can. But if it is 1 over x dx, it is going to be a log function. So that is why except 1, -1. We said except -1. So this is a log function. So if you do it, integration of x to the power -1, if you say x to the power -1 minus +1 -1 plus 1, this is a wrong way of doing it. So if it is x to the power -1, it is a log function. So that is why we said earlier, the beginning, except for -1, right? Is it clear to everyone? Right. Right. You have plenty of examples in the tutorial you can try. I will give you some other examples. Let's say integration of e to the power u dx. This is another rule. So this will be given as e to the power u plus c. Right? So integration of e to the power x with respect to x is given as e to the power x plus c. Right, integration of e to the power 2x dx. How to get this? E to the power 2x plus c. Fine. Now, if you differentiate, can you get this? If you differentiate this, it becomes as e to the power 2x into 2. How to cancel this 2? How to get rid of that 2? If you multiply by 1 over 2, then it will be cancelled out. Similarly, e to the power 3 or 4x, integration of e to the power 4x. Similarly, e to the power 4x plus 3. If you differentiate, it becomes as e to the power 4x into differentiate this component, that become as 4. So we'll have to get rid of 4. How to get rid of it? Add a multiplicative component 1 over. So that is the answer. Right? Any questions? Integration of e to the power 10 with respect to x, 10x. So you can write it as 1 over 10 directly into e to the power 10x. That's it. Any questions? Any questions? Any questions? All right. Next one, integration of sin x dx. Integration of sin x dx. Anyone?
Minus cos x
Minus
plus
cos
c.
plus c. So you should have remember the differentiation also, because this relationship is, even though integration, if you do it other way, it is a, sorry, if this relationship is a integration, the opposite way is differentiation. So when you differentiate, you'll have to get the same answer as it is. All right. So it is minus cos x plus c. Integration of sine 2x dx. Think about like exponential function that we have gone through just now. Anyone? If you reverse the process, it should be reverse mean if you take the differentiation, it should be sine 2x. So
Minus half cos 2x.
yes, if you write cos 2x, right? If you reverse the process, let's say minus cos 2x. If you reverse the process, fine, one component is sine 2x. Good. Now, if you differentiate 2x, it becomes as 2. So where to go this 2? Right? So if you say half, that 2 will be cancelled off. So you can write it as minus half cos 2x, sorry, plus c. Similarly, if you write it sine 4x dx, straight away we can say 1 over 4 minus cos 4x plus c. Right. If you integrate cos x with respect to dx, it becomes as linked with the differentiation. Mosquito, there's a mosquito.
It's sin x.
Pardon?
Sin x.
Sin x plus c. If you integrate cos 3x with respect to x, yeah. Anyone? If you integrate cos 3x with respect to x,
1 by 3 sin x plus c.
yes, good. 1 by 3 is sine 3x plus, right? Look at the pattern. Look at the pattern, because if you reverse the process, you get the same answer. Right? 1 by 3 will be cancelled off by differentiating 3x. Right? So, if you can recall all what we have done for trigonometrical differentiation, integration of cos u du, for example, it becomes as sorry, we have done already cos. So we'll go with the tan and others, right? Integration of sec square u, I'll give it in the general form, which is equal tan u plus c. We are not going to talk about much on other functions of integration, right? Integration of cosec square u into du is equal minus cot u plus. This is just for knowing, right? Integration of sec u tan u with respect to u will be sec u plus c. The last one, integration of cot u into cosec u with respect to du is given as minus cosec u plus c. right? Right. Try this one. Integration of a square minus x square dx. This is same as integration of a square dx minus integration of x square dx. Same as that. So here a is a constant. Anyone?
A squared x minus x cubed by 3.
X to the power?
3 divided by 3.
Yeah, this we could say it. If you integrate that, this becomes as a square x, right? Minus, if you integrate that, x to the power 3 by 3 plus. So all these integration are called as indefinite integrals. Why it is indefinite integrals? We are not sure about the value of c, right? All these integration is called as integration as well as integrals is called as indefinite integrals. We have already mentioned that. Right. Now, what is definite integrals? What is definite integrals? So, by definition, definite integral of a function is given as from the upper and the lower limit as lower and the upper limit as a and b, where psi x is the integral of function after substituting the values of a and b. So this is the concept or the background of the definite integrals. I'll take an example. So that is equal psi b is the upper value minus psi a, it is the lower value. All right. So that is also included here. Right. Now I will take an example. Let's say I have a function. I want to integrate that function. Right. I want to integrate that function. That function is x squared dx. The lower value is 2. The upper value is 3. Lower value is 2. Upper value is 3. That is equal. You first integrate this function x to the power 3 by 3. After that, you can substitute these two values, upper and the lower value. So first you substitute the upper value, that is equal 3 to the power 3 divided by 3 minus 2 to the power 3 by 3. Okay, that is equal, right? 27 minus 8, isn't it? So that is equal 19 by 3. So you have an absolute value answer. What happened to C then? Anyone? We don't apply C here. We get a actual value. What has happened to the C? Anyone?
It can be cancelled, sir, because one time added and other time subtracted.
Exactly. So here, if you say plus C, So here you say plus C, here plus C, right? What will happen? This is a plus C. This become as, because of this minus, it is minus C. So this will cancel out. C will cancel out. So that C is not coming into consideration. So that is why it's called as definite integrals. You have the actual values. Clear to everyone? Right. Now we are going to play with a couple of definite integrals. Try this. Integration of x square plus x dx, where it is from 2 to 3. Find out the answer. Anyone? You differentiate that. Sorry, integrate that x to the power 3 by 3 plus x square by 2. All right. You substitute the value 2 and 3. You substitute the value 2 and 3. That is equal 3 to the power 3 by 3 plus 3 to the power 2 by 2 minus 2 to the power 3 by 3 plus 2 to the power 2 by 2. Okay. So you can take 27 by 3 plus 9 by 2 minus 3 by 3 minus 2 by 2. And cancel it, isn't it? So this becomes as 19 by 3. Okay. And 4, 5. This is plus 5 by 2. Right? What is the answer? This is 6 by 38 plus 50. That is equal 53 by 6. Do you all get the same answer?
Yes, sir.
Yeah. Right. Any questions on those two aspects? Definite and indefinite integrations. Right. Now I will give you some more work. Everybody go through it and do it. we need more exercise on that. So integration of 2x plus 1 into x minus 2 dx. Yeah, it is from -1 to first of all, here we have two multiplicative functions. We haven't gone through how to integrate two multiplicative functions. Later we will see. But here at this moment, we didn't talk about two multiplicative functions. So how we can handle this? Anyone? Yeah, because somebody has already said, written to me, there's a internet problem from your side. Actually, you'll have to correct that we cannot do anything beyond that. Because either we'll have to bring all of you to have a lecture here. If it is so, no problem, internet. So we give a chance for you all to stay at your home and learn it. I am always not speaking to student, speaking to computer, speaking to my laptop. Right? For me, it is boring sitting and looking at the computer all the time. Right? So even though we offer online, assuming that all of you have internet facility, so that you will have to sort it out. I cannot sort it out the internet problem. Otherwise, everybody can come to PGI and do the lecture, follow the lectures, right? So internet problem is up to you all. That is not my problem because already we have the schedule. So you'll have to get ready with the internet. Otherwise, you buy an internet facility and you'll have to do it. I cannot buy internet for you, right? So therefore, everyone, whoever follows this course, get ready with connectivity. That I cannot give an excuse. I mean, for me, from my point, we cannot do because only possibilities we can upload the lecture after completing the lecture. I cannot upload before that. No. There's a recording going on. Once the recording is over, today or tomorrow, they will upload the lectures. So you can follow through the lectures again and fill up the missed part from your side. That's all I can do. Right? Internet connectivity is beyond my control. Right? Okay. So somebody has already informed me there's a drop in their internet side. Their side internet problem is there. So I cannot make it anything. Right? Right. How we can solve this? First, we want to bring it this in form of, all right? How we can solve this?
Solve the brackets and remove it.
Yeah, it's okay. We can directly multiply them and see. All right. This is how we can check it out. So this is 2x squared minus 3x minus 2 dx from -1 to 2. So this is a simple way, right? Can you get the answer? Everyone who working it, get the answer.
Minus 11 over 6.
Minus 11 over
6.
Anyone getting more or less same answer? So this we could say 2x to the power 3 by 3 minus 3x square by 2 minus 2x, right? Minus 1, 2, 2. Let's be careful with these minuses and pluses, right? Okay, the integration is as such. So you put now substitute the value 2x to the power 2 to the power 3 by 3 minus 3 2 to the power 2 by 2 minus 2 to the power, 2 to 2. So this is one component minus 2 into minus 1 to the power 3 by 3 minus 3 into minus 1 to the power 2 by 2 minus 2 into minus 1. So this is how it works. So that is equal 2 to the power 3 is 16 by 3 minus 12 by 2 minus 4 minus minus 2 by 3 minus here this is 1 into 3 by 2 plus got it? Now solving further. By 3 minus 12 by 2 minus 4 right, plus 2 by 3 plus 3 by 2 minus 2. So that we can take the common term 6, correct? So 32 minus 36 minus 24 plus 4 plus 9 minus 12. So what is the answer now? Anybody?
Minus 27 by 6.
Yes, minus 27 by 6. So you can minus, maybe if you divide by 3, minus 9 by, okay. Right, another one, integration of x square 3x, x square minus 3x plus 2 dx from 1 to 2. Try this one. Anyone? What the answer?
2/3.
Yeah,
2/3.
2/3. Anybody got the same answer? This is x to the power 3 by 3 minus 3x square by 2 plus 2x from 1 to 3. So you substitute the value and see. Anybody got the same answer? Try this. X to the power, let's say 3 by 2 plus 2x plus x to the power minus 1 dx from 1 to 4. So first integrate this function. First integrate this function, then you can substitute. When you integrate that function, x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 2x square by 2 plus x to the power minus half plus 1 divided by minus half plus 1. Right? So that is given as x to the power 5 by 2 into 2 by 5 plus x square plus x to the power half 2x to the power half. You see? Now you can substitute and get the value. Right? All right. One more example. X square plus x plus 1 whole thing divided by square root of x dx 1 to 9. Right? This is same as, first we'll have to integrate this function, x square plus x plus 1 whole thing to the power, x to the power, sorry, whole thing multiplied by x to the power minus half dx from 1 to 9. Right? Now you can integrate that function in a normal way. Before that, we'll have to multiply this integration from 1 to 9. Multiply that x to the power 3 by 2 plus x to the power half plus x to the power minus half. Isn't it? You multiply that x to the power minus half. Right? Now you integrate that function. Similar to the earlier one. So if you integrate that function, it becomes as x to the power 5 by 2 into 2 by 5 plus x to the power 3 by 2, 2 by 3 plus x to the power half 2. Now we'll have to substitute that values. You need to substitute the value, get the final answer. Right. Now let's move to other ways of solving the integration. It's called as integration by substitution. Integration by substitution. So you integrate a function 3 into 2x plus 1 to the power 4. Now you see power 4, right, to the power 4. Here we consider u as 2x plus 1, right, u as 2x plus 1, so that we could write it as integration of 3 into u to the power 4, right? Okay, we simply say 2x plus 1 is considered as u. Now what we want to do is, this is in u form, this is in dx form. So we'll have to bring this also into u form, du form. For that, we can use this u. So that is du by dx is equal. What is the derivative of that? Du by dx is equal to. So from that, we could say dx is equal du by 2. Can we write like that? Okay. Right. Now we can substitute that instead of dx, du by 2. So integration 3 into u to the power 4 du by 2. Now we can take all the constant out of the integral sign. So 3 by 2, we take out of the integral sign u to the power 4. Now we can integrate that function with respect to x. The constant remain as it is, u to the power 5 by 5 plus. Now we know what is u. We know what is u, that is 3 by 2 into, so we say 3 by 10 into, what is u? U is 2x plus 1 whole thing to the power 5 plus 6. So that is my answer. Any questions? So that is by substitution. Integrations by substitution. We'll do another one. Integration of 2x plus 5 whole thing to the power 3 dx. So we can consider u as 2x plus 5, so that we could write it as integral of u to the power 3 dx. So this is in u, this is in dx, we'll have to convert it. For that we can use this, right? U is 2x plus 5 du by dx is 2. From that, we could say dx is equal to du by 2. So integration of u to the power 3, instead of dx, we can say du by 2, right? So take the constant out of integral sign. So we could say half into integration of u to the power 3 du. So we are going to integrate with respect to u. So that is equal half into u to the power 4 divided by 4 plus c. Right? So that is equal 1 over 8 into u. What is u? U is 2x plus 5 to the power 4 plus c. All right. Any questions? Any questions? Try this one. Integration of x to the x plus 5 to the power 5 dx. Try this. Anyone? Simple, isn't it? We consider u as x plus 5. From that, du by dx is equal 1. So dx is equal du. Is it? So integration of u to the power 5 dx, u to the power 5 dx. So here, instead of dx, we say u to the power 5 dx. All right? So you integrate that u to the power 6 by 6 plus c. So we know that u is x plus 5. So that x plus 5 to the power 6 by 6 plus. That is the answer. Right. Another one. Integration of x square plus 1 to the power 3 into x dx. So here we cannot simply multiply the x with the given component, so that take u as in an earlier way x square plus 1. From that, du by dx is equal to 2x, so that dx would be du by 2x. Keep that aside. Now we can rewrite it as u to the power 3 x dx. So this is in x, this is in u, this is in x. So we know that we can replace this by du, so that integration of u to the power 3 x into du by 2x. So here x cancel off, so that I can bring 1 over 2 in front of the integral sign. That is equal half into integral sign u to the power 3 du. So that is equal half into u to the power 4 by 4 plus. We know that u to the power 4, we set u is equal x square plus 1, so that we could say x square plus 1 to the power 4 plus, so that is what final answer. Similarly, you can try this one, integration of 2x square plus 1 whole thing to the power 3 by 2 into x dx. So here u is 2x square plus 1. From that, you could see du by dx is equal 4x. From that, dx is equal du divided by 4x. So rewrite it as u to the power 3 by 2 into x into dx. So that we could say, we could write it as u to the power 3 by 2 before integration into x into dx can be written as du by 4. So x cancel out, so you can write it as 1 over 4, take in front of the integral sign, u to the power 3 by 2 du. That is equal 1 over 4 into integrate that u to the power 5 by 2 into 2 by 5. Okay? 2 by 5 into, yes, plus, so that is equal 2 by 20 u to the power 5 by 2 plus 6. So the last point is, if you replace that, 1 over 10 into 2x squared plus 1 to the power 5 by 2 plus. So this is your final answer. Any questions? Try this one, integration of 3x squared, sorry, 3x to the power 3 plus 5 into x to the power 2 dx. Right? Try another one as a homework. 3x to the power 3 plus 5 to the power 9 x squared dx. Why I gave is this? You can multiply directly because there's no power here. So you can multiply there directly before we solve it for the integration. But here we cannot do that because power 9 is already there. Right? Right. We will see one Couple of more examples very quickly. Integration of sin x cos x dx. Integration of sin x cos x dx. You can take u as sin x. If you take u as sin x, what is du by dx? Anyone? What is du by dx?
Cos x.
Cos x. From that, we could say dx is equal du by cos x. Keep that aside, then we could write it as sin x instead of sin x, u into cos x dx. Isn't it? So that we could say here this is in u, this is in x, this is in dx. So we can substitute the dx by du. So u into cos x into du by cos x. So here cos x cancel off. So we integrate u to the u into du. So that is u square by 2 plus. So we know that u is equal sin x. Sin square x by 2 plus. So that is my answer. Right, here in this example, we consider u as sin x. Suppose if I consider the same example, sin x, cos x, dx. Here if I consider u as cos x, that is also possible because two components are there. Then how to handle it? Du by dx is equal, anyone? If you
Minus sin x.
minus sin x. So dx could be given as minus du by sin x. Keep that is away, and we can fill the blank. Sin x u into dx. So we substitute the value for dx, that is integration of, integration of sin x into u into dx. Instead of dx, we can write minus du by sin x, right? Then take the minus sign in front of the integral, right? This sign will cancel off with this. So you end up with u into d, right? So that is equal minus into u to the power 2 by 2 plus c. You know that you have consider u as cos x. So minus cos square x by 2 plus c. So you see, for the same integration, you have two possible answers. All right. For the same function to be integrated, there may be two possible answers. It depends on, because you differentiate, you will get the same answer. If you differentiate, you get the same. Right. In this line, the last example, integration of sine to the power 5x cos x. Here you cannot cross the u. Here you can consider only one term as u. You can't take either sine or cos as u. Here you can take only sine as u. Sine. From that, du by dx is equal cos x. From that, dx is equal du by cos x. So that you can write integral of u to the power 5 into cos x into dx. So as we said already, we cannot keep it on dx form. So we'll have to bring it into du form. So u to the power 5 cos x into du by cos x. So as you all know, cos x will be cancelled off, so that you could write it as u to the power 5 into du. So that is, if you differentiate, u to the power 6 by 6 plus c. Again, go back and place your u as sin x. So to the power 6x by 6 plus c. Any questions on this? Any questions? I'll give you a couple of minutes to ask any questions. We haven't completed the integration. This will be continued next week also. Any questions? All right. If not, we will go for the quiz, isn't it? Any clarification, questions? Any clarification, questions? If not, we'll go for the quiz. Right, this is the quiz. Find the limit of the following function. Find the limit of the following function. Give me a second, I will check. Right. So this is the function. Limit of a function x square minus 5x plus 6 divided by x square minus 4 when x reaches 2. Find out the limit. Okay? Right. Okay, carry on. more minute. Okay, see you next week on next week Saturday in the morning.